We're delighted to share with you a brief summary of Chapter 24 of the Computer Science in K-12 book. This chapter is called Crossing Boundaries with Physical Computing, and it's by me, Sentance, and my co-author Katharine. We're both from the Raspberry Pi Foundation. We'd like to share with you some of the highlights of this chapter and what we think teachers will really find useful reading it. So firstly, we outline what physical computing is, the background and the benefits. We've included this great full-page table of devices, categorised into different types of devices, with lots of examples that we think teachers would find useful. We've also got a section on tips and things that we've learned from experience, with a focus on good pedagogical practice and how to plan an effective lesson with physical computing. We've got some examples, one from secondary and one from primary, and we're going to talk about those a little bit more in a moment. And finally, we look at the barriers and the obstacles, and we thought it was really important to face these head on and acknowledge some of the obstacles, but also think about some of the solutions. And we talk about how to get your classroom really organised so that you can make the best use out of the time that you have with your students and physical computing. And finally, we have lots of signposts to resources, some further reading, and that enables teachers to look a bit further into this topic. So now Katharine is going to give us a little bit of a practical.
Thanks, Sue. One of the activities in the book chapter is to create a BBC microbit pedometer, just like this one. This uses the onboard accelerometer to detect motion. So every time the BBC microbit is moved by taking a step, 1 will be added to the step counter here. Let's simulate that now by giving it a shake. Okay, so you can see that's how it works. Every time the microbit moves, the step counter increases. The second activity in the book chapter uses a sense hat, which connects to a Raspberry Pi computer to add some functionality. We've used the temperature sensor and the humidity sensor on the Sense hat to create a weather station activity. I'm demonstrating this in Trinket, where I've got some code written in Python. I'm going to run this and use a simulator of the Sense hat here. We're looking for a temperature of above 30 degrees and humidity above 80%, and we should get, there we go, a warning symbol.
So that's all from Katharine and me. We really hope you enjoy reading our physical computing chapter, and we wish you all the best with your physical computing adventures.